Hey everybody, hope you're having a great day today. Start off, sorry, I kind of messed up on this one yesterday. I hope didn't cause too many of you anxiety. A couple of you came to the open meet and asked questions. That's when I realized that I did not do this one properly. So just want to explain it now. Hopefully you will now understand how to do it. So real quick, so you write y equals 4x squared. And then, you're solving for x, so you divide by 4, as we did in the last video, and equals x squared. Now, the thing I didn't do in the last video, whenever you have a variable being squared, when you take the square root of both sides, the other side becomes plus or minus the square root of y over 4. So it becomes plus or minus the square root of y over 2 equals x. So there's a plus or minus in front of here. So then when you plug in 4, you would have positive and negative 1. So x would be 1 and negative 1. So that's why yesterday there was 2 inputs for that, because there should have been a positive and negative of the answer when you take the square root of both sides. So that was from yesterday. For today, we're going to talk about finding inverses of functions algebraically. So basically it's the same thing that we finished up with yesterday, except one last part is that at the very end where you see y, you're going to write x, and where you see x, you're going to write f of x. So you're going to do the same exact thing as before, as yesterday. Same exact thing, and then just at the very end, you're going to switch the, you're going to turn y into x, and x into y, or in this case, f of x. Alright, so for this problem, we're trying to find the inverse of f of x equals 4x minus 9. So, like we did yesterday, you're going to turn this into y, keep x the way it is. Now, what the directions say is they say switch it at this point, but it doesn't matter when you switch it, either switch it now or switch it at the end. It's just eventually you're going to switch where the x and the y are. So if you'd rather just solve for x here like we were doing yesterday, so you'd add 9 to both sides. And that would equal 4x. And then you divide both sides by 4. And so x would equal y plus 9 divided by 4. Now, the only difference between this and what we did yesterday is the last thing we're going to do to find the inverse, you just write, at this point, y equals x plus 9 divided by 4. Or if you wanted to, you could have it 1/4 x plus 9/4. And then at the very end, f of x equals x plus 9 divided by 4. So that's the only difference. Okay, so the only thing is you just switch where the x and the y are. So if you wanted to do it first, you could have done it right here and just right in the beginning said x equals 4y minus 9 and then solve for y at that point. That's fine. You would have gotten the same exact answer. It wouldn't have mattered. It's just that's how you find the inverse. Now, what is the inverse function? An inverse function is a reflection over the line y equals x. So it's a reflection of the line y equals x. That is what an inverse function is. So that is what you're finding with these. All right, so there's these 3 problems here. It says find the inverse of the function, then graph the function and its inverse. So what I want you to do is what we just did in the last slides. Solve for the x and then switch the x and the y, or you can switch the x and the y first and then solve for y. The graphing, they're just going to be, again, reflections over the line y equals x. So remember that, and you're just graphing 2 lines. You just graph the original and then graph the new function as well. So pause your screen, try these out, and then press play when you're ready. Okay, so for number 6 here, I'm going to switch the x and the y first. I'm going to do things a little bit different here because this is the faster way to do it. So you switch the x and the y first, and then you just solve for y, and you get y equals 1/6x, or x over 6. So if I was going to graph these two, The first one I would graph is f of x equals 6x. So that means I have point at 0, 0, 1, 2, 3, 4, 5, 6. Alright, so this is the original. And then if I was going to graph the inverse, it is y equals 1, 6x. Do that one in red. So again, that starts at 0, 0, and it goes up 1, right? 1, 2, 3, 4, 5, 6. Down 1, 1, 2, 3, 4, 5, 6. So that is your graph. Now again, it is a reflection over the line y equals x. That's pretty much it right there, the y equals x line. 1, 2, 3, 4, 4 right there. So that would be the reflection over this line. That's the inverse. So this is the original. This is the inverse function. So that's how the graphs are going to look. All right. For number 7 here, the first thing I'm going to do is I'm going to switch the x and the y first again, just because it's just a little bit faster, I think, to do it this way. I'll subtract 5 first, so I'll have x minus 5 equals y, negative y, and divide everything by negative 1, I would get y equals negative x plus 5. Now, you might be saying to yourself, well, that's the same exact line, right? I mean, look at this and this, they're the same thing, so how could that be possible? Well, let's take a look at the graphs here. So negative x plus 5. So 1, 2, 3, 4, 5. Negative x, so we got a dot there, dot there, dot there, dot there. So there's both lines, the inverse and the original, right? Because it's the same line. And then, as I said, it's reflected over this line here, this y equals x line. That. So if you think about it, if you reflect it over this line, it's just going to land on top of itself. So that's why the inverse is the same exact function. So they're exactly the same. The inverse and the original are the same because when you reflect it over the line, y equals x, it would just land right on top of itself. So the last one here, again, I'm going to switch my x and my y to start off. Minus 1. So add 1 to both sides. Multiply both sides by 4. And then we'll go ahead and graph. So we got 1/4 x minus 1. Draw my line through that. Alright, picked the wrong line, but that's alright. And 4x plus 4. So 1, 2, 3, 4. There we go. And it looks something like that. Alright, so those are the functions and their inverses, and then those are the graphs. So again, to find the inverse function, you just switch the x and the y and then solve for y, or you solve for x and then switch the x and the y. Same exact idea, and then you get that as your final answer. Okay? And then the only thing that I forgot to do on these, just looking at it now, is these wouldn't be y. You would change it to something else besides for f of x. I think on the last one I said f of x at the end, right? So this should have been g of x, or just something different, just not f. So g, h, anything else. It just has to be a different letter. So at the end, to write it back in function notation, you would just write each one of these with a different letter, unless it's stated what the letter was, other than f. It's not the same function as the inverse. So you make this g of x and I of x, whatever you feel like, make it. Alright, so that's all we're going to work on today. We're going to do it with the linear ones. Tomorrow we'll do it with the quadratics. So why don't you try out the big ideas, and if you have any questions, please come on by and open meet, or if you just want to say hello, come on by, and otherwise write your questions in the Google Doc. Alright guys, have a good day.